2.3b, product and quotient rules and higher order derivatives, page 40 on your notes. For this segment, I'm going to introduce the derivatives of trig functions. So here we have sine, cosine, tangent, cotangent, secant, and cosecant. Now they're derivatives. I'm not going to deal with the graphs right now, but if you recall, the derivative is the slope. So if I wanted to find the slope of the sine function, it ends up being the exact same as cosine. So the derivative of sine is cosine. Now, the slopes of cosine end up being the same as a negative sine. So it's sine, but upside down. Tangent, when I derive tangent, I get secant squared x. And then, okay, so like, I wrote these out in a certain way. Okay? If you recall the trig identities, or not the reciprocal identities. So for example, sine. Sine is the same as 1 over cosecant. Cosine is the same as 1 over secant. If you look at the derivatives here, let me get a highlighter. So cosine is the reciprocal of secant, right? So I kind of wrote these out in columns that they're somewhat related. So if tangent yields me secant squared, then cotangent, which is the reciprocal of tangent, is going to yield me cosecant squared. Oh, that's red. I want black. The only difference is secant squared x. You see how this is negative? Well, so is this. Okay? Secant gives me or yields me, I need a marker, black marker. Okay. Secant yields me secant, oh, I thought I changed the marker. Okay, it's red. Marker's not doing what I wanted to do. It yields me secant x, tangent x. Okay, so secant, tangent, right? Cosecant yields me cosecant x, right? Cotangent x, but once again, negative. And once again, okay? Maybe this will help you memorize these, because you do have to have them memorized. Again, the derivative of sine is cosine. The derivative of cosine is negative sine, okay? Tangent is secant squared x. Cotangent is negative cosecant squared x. Secant, the derivative of secant is secant x tangent x, but the derivative of cosecant is negative cosecant x, cotangent x. Okay, so we're going to use these. Example 5. Again, the numbering might be off. Find dy dx if y equals 2 over sine x. So it's actually fairly simple, but I want to make sure I go over that sometimes these equations can be rewritten. So this could be 2 times 1 over sine x. And then I need to refresh my memory on, 1 over sine x, right? This is the reciprocal. It is cosecant x. So really what I have, this equation is 2 cosecant x. So when I do the derivative, y prime, it's going to be 2 times negative cosecant x cotangent x. And then the negative, I'll just bring it to the front. And there you go. There's my derivative. Y prime is negative 2 times cosecant x cotangent x. Okay, example 6, find y prime. Okay, so I have two parts, A and a B. B is down here somewhere. So here we're going to use trig, but if you pay attention, I have a u times a v. This is my u, this is my v. So I'm going to have to do the product rule. And if you don't recall, the product rule is u times v prime plus v times u prime. So it would be probably a good idea to figure out what u prime is and what v prime is. So u is 2x, so u prime is 2. V is cosine x, so the derivative of that is negative sine x. So now that I have all my pieces, I can go ahead and do that part. So y prime is going to equal, I'm going to do the product rule in the parentheses here. I hope that's enough space, we'll see. So u is 2x times v prime. So let's see, v prime is negative sine x. So negative sine x plus v was just cosine x, times u prime, and u prime was just times 2. Oh, it was more than enough space. Let me make it a little smaller. Okay, so that right there is just the derivative of this. Okay, can I make an arrow? I guess I can't. Alright, then the continuing, or the rest, so minus, and the derivative of 2 sine x is 2 times cosine x, right? Because the derivative of sine x is cosine x. So this is what I have. Let me simplify it, clean it up a little. So y prime, let me change that to black so that you could see the blue stuff is the product rule. Okay, so y prime, so let's see, negative, oops, I touched something. Oh boy. Okay, back at it. So negative 2x sine x plus 2 cosine x minus 2 cosine x. Oh, look what happens. I have a positive and a negative. So let's stay with marker black. So now I just have negative 2x sine x. And there's my answer. So we did a product rule, and it involved trigonometry. Example B, it's 3x squared. That's one function, and then cotangent x is another. So it's just u times v. So u prime is 6x. V prime is, okay, so you might have to look at the top of your page, right? Cotangent, if you remembered, goes with cosecant. Okay, the way that tangent goes with secant. Okay, so it's negative cosecant squared x. It really does help. Cosine, secant, and tangent, all positive. Sine, cosecant, cotangent. They'll associate them with negative. Okay, so here are my pieces. Let's do black. So y prime is going to be u. So u is 3x squared. So it's u times v prime. So v prime is negative cosecant squared x plus v. Let's see, v was cotangent x. So that's an x times u prime, which was 6x. And then simplify this a little. So let's see, negative 3x squared cosecant squared x plus 6x cotangent x. And there's my answer. That's a C, by the way. Looks like a little P. I don't know. Okay. And there you go. I don't really see much that can be done here. Well, cosecant is 1 over sine, and cotangent is cosine over sine. But no, we're good. Next. Example 7. For example 7, we're just continuing on, or, it's trig. But we're either using the product rule or the quotient rule, or or b, neither. Um, so find the slopes. Again, you have to train yourselves. Slopes means derivative. Okay. And we don't have anything to plug in, so I'm not actually finding the exact slope. We're finding a general equation that'll get us the slope at any point. That's what the derivative is. So the first one, let's call this u on top, and this is v. So therefore, u prime is the derivative of cosine, which is negative sine x. And then v prime is the derivative of 1 minus sine x. The 1 becomes 0, and then the negative sine x becomes cosine x, but the minus, right, is negative. So again, the derivative of sine x is cosine x. But because there's a minus, that's why my derivative is negative. No other reason. Now the derivative of cosine x is negative sine x. So that's why that has a negative there. Okay, so let's do it in black. H prime of x. So this is going to be low d high minus high d low over low times low, right? And I'll write it on the top up here. So v times u prime minus u times v prime over v squared. All right, so v. V is 1 minus sine x times u prime, which is negative sine x, minus u, which is just cosine x, times v prime, which is negative cosine x, over 1 minus sine x squared. Okay, so let's move down. Let's see, let's simplify a little. 1 minus, if I distribute this, I get negative sine x plus sine x squared, right? And then minus, oh wait, if I multiply these two, which happen to both be negative, ends up being positive, positive cosine squared x. And then dig deep, deep inside your brains for some trig identities that you learned last year in pre-calc. Let's see. What I'm talking about is this right here. If you can recall, sine squared x plus cosine squared x, it's the Pythagorean identity, and it's supposed to equal 1. So that means that I can actually simplify that part of the equation here, function, and I'll have negative sine x plus 1 over 1 minus sine x squared. So I'm moving further along here. What if I put the 1 in the front? The 1 minus the sine x over, oh look, 1 minus sine x. The only difference is that the bottom is squared, so when I simplify, I can simplify 1 from the top, leaving 1 behind, and 1 from the bottom, leaving a 1 minus sine x behind. And there's my answer. Alright, b. Along the same lines, b is a little more complicated. Sometimes you will get functions that you can simplify using trig identities or Pythagorean identities or the reciprocal functions, or, like any of these. B, you have to really see it. I don't, but it could be. There could be questions as challenging on the AP exam as B, but I would believe that they're more like part A here. Okay, so for part B, there's no product rule, no quotient rule. It's just straight up deriving. So f prime of x equals. Okay, so the derivative of cosecant. Oh, and that's another thing. This should be theta, right? My variables should all be the same. I must have made a boo-boo. What's new? Okay, so the derivative of cosecant is negative cosecant cotangent. So this already has a negative. So I'm just going to write the negative and then it's another negative cosecant cotangent minus the derivative of sine. So the derivative of sine is cosine. So cosine theta. Okay. So I can simplify this a little because the two negatives become positive, so great. Cosecant theta, cotangent theta, minus cosine theta. Now, this could be your answer. It is. This would probably be on like a multiple choice, and the answers listed would not be this right here. So you'd have to simplify, or rewrite, or figure out what identity to use. Okay, so cotangent. Cotangent, if you recall, cotangent is cosine over sine, or 1 over tangent. So let's see, cosine over sine. So what if, because there's a cosine here, what if I rewrite it? So let's see, cosecant theta times cosine theta over sine theta minus cosine theta. Okay, so I see that there's two cosines. Let me use a highlighter. There's one here, one here. The sine, however, is in my way. So what if, just using regular laws of math here, I split it up so that now it's cosecant theta times 1 over sine theta times cosine theta minus cosine theta. So again, right, there are my cosines. What if I decided to factor them out? I factor them out of the function, one from each term, because I only have two terms. This is one term because they're all being multiplied, and here's another. So basically, follow along here, I have 3x minus 6, and I see, ooh, those two numbers have the number 3 in common. So I factor it out. I have 3 on the outside now, x minus 2. That's what I'm going to do here. Okay, this was just to show you what I'm doing. All right, so let me erase that. I'm going to factor out the cosine theta. Let's do that in blue, right? Yeah, okay. So factor out the cosine theta. So I've taken that out, and I've taken this out, but in its place, this one has a 1. So, well, they both do, right? In its place, they leave behind a number 1. Okay, so cosine theta. So then I have cosecant theta times 1 over sine theta times 1 minus 1. Okay. Now, I didn't want to do this all at once, but what does 1 over sine theta change to? And hopefully you're like, oh, 1 over sine is cosecant theta. So this is now cosine theta, and then these, let me do it another color. Now these I'm going to join together. But instead of 1 over sine theta, I'm going to use cosecant theta. Okay, so again, this is cosecant theta, so I'm changing that out for cosecant theta. So now what I have is 2 cosecant thetas being multiplied, right? So cosecant squared, and then minus 1. Okay, so now I need you to recall another Pythagorean identity. So earlier I said sine squared plus cosine squared equals 1. Well, there's the one I'm trying to get you to recall is another Pythagorean identity, which is cotangent squared theta plus 1. You know what? Let me write it. Let me just write it. So I'm talking about cotangent squared theta plus 1, and that's going to equal cosecant squared theta. Just like sine squared theta plus cosine squared theta equals 1. Okay? I mean, they're not exactly alike. Now, what I have here is not exactly this, right? There are some differences. Now what's the difference? I have cosecant squared theta minus 1. Okay, well, it's not a problem really. Think about it. Subtract 1, subtract 1. Now I have cotangent squared theta equals cosecant squared theta minus 1. Voila! This is exactly what I have up there. So that means that this equals cotangent squared theta. And then I have cosine theta, and they're being multiplied, and that's it. That is my answer. Okay. Homework, you actually don't have any answer problems. So, see you in class.